Okay, we have now a compound gear train. And so notice with this compound gear train that B and C are connected on the same axle. Okay, so B and C are not going to be interlocked with teeth. They're connected on the same axle. So when A causes B to turn, that will also cause C to turn, which will then cause D. Okay, so let's get started here. The first thing we got to figure out is what are the teeth of each. So I see that's a small one, that's 12. So far I have A has 12 teeth. I have B with 36 teeth. I have C is another small one that has 12 teeth. And I have D is going to have 60 teeth. Alrighty? All right. So that's part one of this compound gear train. Then it asks, what is the gear ratio of B to A? And you know what? I'm going to move it over here. So B to A, what's my gear train ratio? My gear ratio is going to be 36 to 12. And I can divide both of these by 12. And I get a gear ratio of 3 to 1. All right. Now, the other gear ratio I need to know is D to C. And D to C is going to have a gear ratio of 60 to 12 as well. Okay. So I have D to C is 60 to 12, so I can simplify those as well, dividing both of those by 12 also. And I get 5 to 1. Okay, next it asks to convert into fractions and multiply out. So I got a 3 over 1 times a 5 over 1. And that gets me my new gear ratio of 15 over 1. Okay, which also can be written as 15 to 1. Okay. All right. Finally, you're going to be given some type of input, and I'm just going to make up an input. Yours could be very different number, but let's say that I have a input of 9.2 as foot-pounds as my torque. Okay, so foot-pounds would look like that. So if I had a gear ratio of 9.2, well, gear ratio is equal to torque output over torque input. So I can do my gear ratio is going to be 15 over 1 is equal to my input, which is going to be 9.2, yours will be different, over torque output. All right, I can do a little algebra to multiply both sides by, oops, I don't know why I did 9.2. All right, so I can do, I'll move this around here. There we go. All right, so I can multiply both sides by my value, which I have 9.2. Yours will be different. 9.2. That's gone. And so my output torque will be equal to my input torque times my gear ratio. I can multiply that out and get my answer. Okay, there you go.